All right, in this video, we're going to talk about, we understand how to calculate the CPI, and we understand why inflation is important. In this video, we want to understand how accurate is the CPI at actually recording inflation. So overall, we say that there's 4 biases that are present in the CPI, and that these are going to bias the CPI upwards, and so we want to understand what they are. All right, so these are biases in the CPI. So we assume that we calculate the same basket of goods every single year in the CPI. So consumers 10 years ago are purchasing the same things that they are buying today. And we know that's not obviously going to be the case because people respond to prices. So if we think about demand curves, a demand curve is downward sloping. Or what that means is that if the price rises, I'm going to buy less of it. So for example, if let's say that apples are not included in the CPI, but oranges are. So in the CPI, we calculate oranges and the price of oranges goes up. It's going to assume that I'm purchasing the same number of oranges at a higher price, so I'm spending more money. However, in reality, I can overcome some of that price increase because I say, well, instead of buying oranges, I'm going to buy apples, which didn't increase in price. So when price of oranges goes up, I substitute away from oranges and substitute or buy apples instead, which didn't go up in price. So some of that price jump I was able to avoid simply because I bought less of that good. However, the CPI doesn't take that into account. It assumes that we don't respond to prices. And we call that the substitution bias. Okay, or it's assuming, CPI assumes we purchase same number of goods and services. Regardless of the price. But we know that's simply not true. Okay? However, the CPI doesn't take into account how we would buy less or more of something depending on if the price went up or down. Okay? So that's one bias that's present in the CPI, is that I can avoid price costs by substituting away from more expensive goods to least expensive goods. Second bias. The second bias involves new products. Okay, so the way that we calculate the CPI is it calculates new products. So this has to do with how frequently the market basket is updated. Okay, so right now the CPI is updated, or the basket of goods is updated every 2 years. Okay, so it used to be every 10 years. But over that 10-year time span, new products became available. And traditionally, these new products are very expensive. However, once a new product becomes that overall fascination goes away, so after a year, the price tends to go down substantially. So a good example might be Xbox Ones or PlayStation 4s. So Xbox One came out, I think it was at $4.99 or $5.99 for an Xbox One. Maybe it was, I think it was $4.99 for an Xbox One. So Microsoft just announced that over the Christmas break, or coming up this year sometime, 2014, so less than 6 months after the Xbox came out, it announced that it's going to dock $100 off the Xbox One, so go from $4.99 to $3.99. Okay, so typically new products are expensive when they come out and then they fall in prices. But because of this, we don't capture that in the CPI because the CPI is updated infrequently. Okay, so new products become available. However, we don't update our basket very frequently. So these new products tend to overestimate how much we're actually paying because after 6 months, the Xbox One is going to cost less than it did on the day that it came out. Okay, the third bias in the CPI is what we call the increase in quality bias. And the increase in quality bias says that as things become better in quality, we would expect the price to increase. So as things become better and better, we expect the price to increase. However, when we're calculating inflation, we're assuming that that product hasn't changed. So if we're looking at Coca-Cola, okay, well that makes sense because we just look at Coca-Cola and it hasn't changed. However, if we're calculating a can of Coke, which is 12 ounces, and now we're including bottles of Coke, which are 20 ounces, so we're going from 12 ounces to 20 ounces, right? We're getting more bang for our buck, essentially, okay? And that increase in quality, or maybe this case, increase in quantity, isn't going to be captured by the CPI. Because if you can't buy a 12-ounce can of Coke and you can only buy a 20-ounce bottle of Coke now, right? Obviously, we'd expect the bottle of Coke to cost more than the can of Coke. So if the cans are what we used to buy 10 years ago, and today we're only buying bottles of Coke, we'd expect the price of Coke naturally to go up because there's more there. However, the CPI is just saying that the average family of four buys a thing of Coke every month, okay? Or another way to look at this is if something becomes better. So a computer typically might have like an AMD processor at the beginning, and then it goes to Intel. When it goes from AMD processors to Intel processors are assumed to be better quality. So as this occurs, we would expect the price of that computer to go up. However, if we're just including a computer in the CPI, this increase in quality is actually overstating the true inflation because you're getting a better quality item. Okay, so the CPI can't differentiate what you're actually buying in terms of quality. It can only tell us what the price has changed. And if the price goes up because of that change in quality, then we just don't really know what's causing that, right? And then the last one is what we call the outlet bias. And the outlet bias is caused by the way that the CPI shops. So the CPI only buys goods and services from retail stores. Okay, so if it's going to buy a book, it's going to go to Barnes & Noble and buy that book. However, how do people tend to shop? Well, you might go to Amazon where the book is cheaper to buy the book. And the CPI doesn't shop at Amazon. It only shops at actual stores. Okay, so overall, the CPI is buying from the most expensive places. Another good example is we tend to buy things at Costco for a family of four. So we go to Costco and buy wholesale rather than retail at Hy-Vee. Okay, so we can avoid some of the expensive places such as Hy-Vee by shopping at Costco, which is wholesale. However, the CPI is only going to shop at Hy-Vee. So it's paying more money for than what a family traditionally would. We call it the outlet bias because of outlet malls were a thing of the past. They were very popular in the past. So outlet malls tended to have the same amount of stuff that you could buy in a store like JCPenney, but for cheaper. So if I go to the Levi outlet, I might buy Levi jeans that are cheaper than what if I found them at JCPenney or wherever I would buy Levi jeans. Okay, so overall, these are the four biases that are present in the CPI. And most economists would tend to say that the CPI overestimates true inflation that consumers pay by about 1.5% to 2%. So if you look at the CPI over a year and it said 4%, we could say that it was probably more closer to 2.5%. Okay, so overall the CPI tends to bias, or it tends to make inflation look worse for consumers than it actually is because consumers substitute away. New products tend to fall in price. We tend to see increases in quality. And then consumers also buy at outlet or wholesale or online as compared to in retail stores. Okay. In the recent years, since 2000, the I think it's the BLS, calculates another version of the CPI called the chain index. So the CPI chained index. And what it's actually doing is it tends to update the basket more frequently. So it's overcoming the new product bias, and it also buys from a variety of different places, so it's overcoming the outlet bias. So the CPI chained index tends to be a more reliable measure of inflation. And if you look at the graph of it, CPI might look like this over time, where it's increased in price, and the chain index, so this is the CPI. And the CPI chain index kind of looks, it shows the same pattern, but the gap becomes bigger over time. So this is the CPI chained index. Okay, so overall, we look at that, and the CPI tends to overstate true inflation, and the chained index is one possible fix for that, is it shows inflation at a less rapid amount by about maybe 1% a year. So it's more accurately getting what consumers are actually paying, or increases in prices for what consumers pay, as compared to the traditional CPI. The last thing that I want to discuss is I want to look at how do we calculate prices in the past in today's dollar, or vice versa. So if we look at like what something cost in the past, so for example, if I say, okay, you had $1 million today versus $1 million in 1950. Okay, well, $1 million in 1950 went a lot further than it did today. So we want to know how much is that $1 million in today's terms. Or what we're doing is we're adjusting for the price increases. So if I had $1 million in 1950, what amounts of goods and services, or how much would I need today to buy that same amount of goods and services that I could buy with $1 million in 1950? So because the purchasing power of a dollar changes, $5 or $1 million in 1950 isn't the same as $1 million today. I could retire off of $1 million in 1950. Today, I can't retire off of $1 million. Okay, so, and that's because prices have gone up. So we want some way to translate what would it take today to get me the same level of comfort with what I would have had in 1950 with $1 million. And to do that, we use the price level. So we use the CPI. Okay, so what we can do here is if we know that the price in the past, so the price today, are dollars today, so we'll say dollars today is going to be equal to, well, we know, I want to know how much money I need today to have the same amount of comfort that I could have in 1950 with $1 million. Okay, so we look at the dollars in the past. That's $1 million in 1950, and I want to translate it to how much money I would need today to have the same level of comfort or to be able to retire. Okay, so, well, I need to know how much goods and services cost. So I'm going to do, well, I need to get dollars in the past into dollars today. Well, if I know the price in dollars today, so I multiply by the price today, and then I'm going to divide by the price in the past. Okay, so what this is telling me, price in the past times dollars in the past cancels out. I multiply by dollars today, or prices today, and that gives me dollars today. Okay, so let's go through an example of this. And a good example is the movie Austin Powers. So it was what year? Was it 1960? Anyway, in 1960, let's say in Austin Powers, right? He gets frozen, and then he gets reawakened in 1995 or whatever, 30 years later. And he said, okay, we're gonna like hold the U.S. government hostage or the world hostage for $1 million. And his number two says, Dr. Evil, I'm sorry, but $1 million isn't what it used to be, right? Our company alone makes more than $9 billion annually. And so, you know, Dr. Eva goes, oh, okay, well, I'm going to ask for $100 billion then, right? So that $1 million in the past isn't equal to $1 million today. So we want to calculate if Dr. Eva was asking for $1 million in, let's say, 1965, we want to know how much would he have to ask for in 1995, 30 years later, to be getting the same amount in purchasing power. Okay, so in this case, we know that he was asking for $1 million in the past. So I'll put 1 mil for $1 million. Okay, then we need to know what was the CPI in 1995 divided by the CPI in 1960. So this is $1 million in 1960. Then we're going to multiply by the CPI in 1995. And the CPI in 1995 was 160.5. Okay, so this is the CPI in 1995 divided by the CPI in 1960. We'll call this 1990, 30 years. Divided by the CPI in 1960, which I believe was 33.4. And that's 1960. So notice how the 1960s clash, and then we're left with 1990. Okay, so this is 4.8. 4.8 times 1 million means that he would have had to ask for 4.8 million in 1995 to have the same amount of comfort as if he would have gotten $1 million in 1960. Or what that's telling me, I guess this is 1990 by the way that we phrase the question. Okay, so by knowing the CPI, I can translate yesterday's dollars into today's dollars, or I could do the opposite, is that I could solve for 1 million if I knew $4.8 million today, how much would have I needed in 1960 to have that same level of comfort? Okay, so the Austin Powers thing says, okay, well, if he's asking for $1 million in 1960, and then he goes up to $100 billion in 1990, then that's a huge jump in his level of wealth, right, after adjusting for inflation.